Hi, this is Jacob. We will continue our the session. In the previous session, we discussed about what is big data, why can't we store in the traditional system. So we require a new solution for that. So we try to explore what is the solution to store the big data. Okay, we will discuss about one by one drawback and how we can overcome it. So almost everybody is aware by this time that there is a framework called Hadoop which can store big data effectively. So we will see the reasons, what is the problems in the traditional database or traditional systems and how Hadoop overcomes it. Okay. First drawback what we saw in traditional system is we cannot store terabytes of data, petabytes of data in a single system or a single server because of the RAM size or storage capacity. So storage is a problem. In a traditional system. Problem in the traditional systems. For example, if your system storage is 1 terabyte, 2 terabyte of data, and we can store maximum up to that capacity only, right? We can, suppose if we get more data, how can we store it? That is the main problem. Hadoop overcomes this problem. How it overcomes this problem? What happens Hadoop is Hadoop connects 2 or 3 machines or systems to form a cluster. Cluster means group of machines. For example, you have 3 machines, each machine has 1 terabyte of capacity. You connect these 3 machines and your cluster capacity will automatically become a 3 terabyte of data. So first connect the machines in a cluster, then you divide the data, more than dividing data, you partition the data. For example, you have 3 terabytes of data, you partition it and you distribute it across the cluster. So that's why Hadoop works on partition and distribution. So whatever data you have, for example, you have 10 terabyte of data, create a cluster, make sure the cluster capacity is 10 terabyte of data, 10 terabytes, and you have 10 terabytes of data, so you partition, distribute it across the cluster. That is the how Hadoop works. First partition and distribute it across the cluster. Diagrams, you just Google it, you can see how the data is partitioned. It's very simple. For example, 3 terabyte of data, it has 3 partitions and distributes across the cluster. In this problem, storage, which is very big problem for traditional data systems or database, is overcome. Hadoop is designed in such a way that it allows to create clusters, it allows to partition the data and distribute it across the cluster. So in this way we can overcome the storage problem in the Hadoop framework. So next, reading is also a problem. For example, might be everybody works in the database, right? MySQL or SQL Server, any relational database systems. You have a one table, you want to select one row, assume first row. You write select star from customers where customer ID is equal to 1. expected is it should retrieve the first row of the table. To retrieve it, it scans entire table. Even it finds the answer in the first row also, it scans the entire table. That is how RDBMS is designed. That is not a drawback, but for our, we have a huge data here, right? Assume we have 10 terabytes of data. So to retrieve just one record, if it starts scanning its entire 10 terabyte of data, it takes performance is the main problem, right? We are searching so many things in the Google. It is retrieving in seconds. Assume if it takes 10 minutes to retrieve result, will you use it? So performance is the very good problem nowadays. So that's why reading a specific record is a main problem in traditional database systems. How we overcome it? Assume you know exact location where your data resides. Just assume it. Then you need to scan entire table, right? You can go to the specific location and fetch it. So here fetches the exact location. Exact means where the data resides. For example, so and so block our data resides. If you know it, immediately you can go and fetch the data from that block and display us. Our life is easy, right? If you really know the exact location. Hadoop can easily give the exact location of the data. You need not fetch or scan entire table. You can go get it and display. So storage and reading, these two problems we can overcome by Hadoop. Okay. How Hadoop fetches the exact location, that we will see later. Even remember, Hadoop can fetch the exact location and display the data on the screen. Okay. Third one, transfer is also a problem. For example, as we discussed earlier, your speed is 10 Mbps. Okay. Your data from application server to database server, no, from database server to application server, you want to move 1 terabyte of data, 10 terabyte of data, even 1 GB. It takes hours. Because your network speed is 10 Mbps, means per second it can transfer 10 Mbps of data. But we are having GBs of data, TBs of data. It takes hours to transfer it. Okay, so transfer is a big problem in traditional systems. How we can overcome in Hadoop system? Hadoop system you can overcome using data localization. Means in front end you write some code, you have one application. Okay, back end we have a data. So your front end data is in application server, back end data it is in database server. So you want to retrieve data from back end to the front end, from database to the application. Okay. Then how it works? In traditional system, entire data, 1 terabyte of data, 10 terabyte of data from database server has to move, which takes hours theoretically. Okay. But in a Hadoop, what happens is, instead of asking the data which is in huge to come to your application, what is the size of your application, size of your code? Should be less, right? Why can't we go and execute on the database? Means instead of retrieving the huge database data to your application server, you move your code to the server where your data resides, execute there itself. Then life is easy, right? You need not worry how much data you are retrieving from back end to here. No need to worry about it. So how we do it, that we will see later. But here you understand, transfer is a problem in the traditional database because we need to transfer so much data, big data, from the database server to the application server. But here it is not the problem because there is a concept called data localization. Like application server itself moves to the database server and execute it. This is called data localization. Fourth one is still no storage problem we overcome, transfer is overcome, read is overcome. But we want some new features in a systems which is going to overcome all the problems in the traditional system. That is nothing but a Hadoop. So what is the other unique features Hadoop is having? Okay, upgrade. For example, till now we are discussing cluster. Cluster is nothing but a group of machines. If you connect 10 machines using in cloud, okay, so you can tell that is a 10 nodes cluster. Okay, because in your cluster you are having 10 nodes, means 10 machines, nothing else. Don't confuse about these words. Okay. For example, you want to put more data into that cluster. So definitely you require more systems, right? It is easy, just add the system. If you really start working on the Cloudera, if you go, you just click add IP, give that IP, save it, automatically another system will be added to your system. You need not worry about do you need to shut down, do you need to restart, because as we discussed earlier, big data systems we cannot shut down frequently because of the data it resides. It takes time to shut down, it takes time to restart. Just assume how much time it takes even to shut down our system. Assume you have petabytes of data, you cannot simply shut down. Even not required in Hadoop, that's what I am saying. When you want to add one mission, simply add it. No need of restarts, no need of, you can upgrade your cluster at any time without restarting. That is the unique feature in Hadoop. No need to restart it. Okay, so this is very important. So almost in every interview you ask how Hadoop is better than the traditional system, why I need to move to Hadoop. That is genuine question, right? Without without unique features, why we need to do the another framework or another technology. So we should be in a position to explain why we require Hadoop. That is the upgrade concept. Okay. Next concept is what happens? What happens if job is failed? In traditional system, job is failed, entire system is failed, right? But we don't want that type of feature in the Hadoop. So Hadoop, what happens is, assume 4 jobs are running as part of one execution. 4 jobs are running, one job is down. In typical traditional systems, entire execution should fail and you get some error. But in Hadoop, what happens is, when one job is failed, immediately another working component come into the picture and start doing it. Okay, actually there is a concept of data node and name node that we will check later. Even you remember now that when one job is failed, entire system need not to be failed and need not be shut down. Immediately another working component come into the picture and they start doing this. It is as simple as it is. Okay, so how it happens, that we will see later. Even remember, when one job is failed, entire system should not be shut down. Another working component come into the picture and start doing the same job. In the way you get the same output without getting any errors. So that is the okay. Job is failed. No need of shutdown. Okay, job is failed. Upgrade, job is failed. The another thing is, when you told a job is failed, then you lose the data inside it, inside that block, right? No, it is not required. There is a concept called data replication. Means by default, Hadoop is designed in such a way that it stores 3 replicates of data. For example, if you have a file of ABC, Hadoop saves it 3 times. In 3 different areas, the same file it saves. So even if you lose the data because of any circumstances, you can retrieve the same data in other blocks. Okay, you can simply retrieve the data in other blocks. Other blocks means this is called a data replication concept. Your data is saved 3 times by default. If you want, you can change that number, you can increase or decrease, but default it saves thrice. So even if you lose the data in one block, you can easily retrieve the data from the other blocks. In the way, you never lose your data. So till now what we discussed, storage we overcome, read we overcome, transfer we overcome, how to upgrade the system, what happens if one job fails, how to get what is data localization, and data integrity is the last. Means whether we are moving the same data or not. That is the data integrity. Whether we have the same data at source and the destination, or whether its data is moved as per our expectations. Means you have source and destination. Assume you have MySQL and you have HDFS. It's source and destination movement, right? So whether exact data is moved or not, that is the data integrity. Hadoop has its data integrity feature. It always tries to move the same data as per it never misses any data. So all these features make Hadoop as a unique thing. So in the next session, we discuss what is HDFS, what is the name node, what is the data node, how we store the data. For example, till now we discussed so many things, right? Reading, transferring, upgrade, what happens if job fails. So in the next session, what we try to do is we try to do how Hadoop is overcoming those issues. We discuss about HDFS, how storage is good. Okay, then we discuss about how Hadoop is overcome all these issues. Thank you.